So, muna itong mga multiple choice questions. Now, let's say, for example, number 1, the atomic number of silicon is B, 14. Atomic number of germanium, 32. The valence shell in a silicon atom has the number designation of C, 3. Hello? Valence shell, no? Number of shells, 3. Valence electrons are C, in the most distant orbit from the nucleus. Positive ion is formed when a valence electron breaks away from the atom, C. Most widely used semiconductor material, of course, A, silicon. The energy band in which free electrons exist is the conduction band. Manang mag-cause of electrical current. Recombination is when C, an electron falls into a hole. In a semiconductor crystal, the atoms are held together by all of the above. Force of attraction or interaction of valence electrons or covalent bonds. Each atom in a silicon crystal has B, 8 valence electrons because all are with other atoms. In a silicon crystal. No. The current in a semiconductor is produced by C, both electrons and holes. So, na electron flow and hole flow. Intrinsic semiconductor is B and C. B and D, I mean. Free electrons are thermally produced and there are as many electrons as there are holes. B and D. The difference between an insulator and a semiconductor is D, or all of the above, A, B, and C. Wider energy gap between valence and conduction band, number of free electrons, and atomic structure, of course. The process of adding impurity, B, doping. Trivalent impurity is added to silicon to create. So, kung trivalent, triva, so, forma ng isa lang ka atom. So, 3 plus 4, 7. Kulag isa. So, may hole. Kung hole, P-type. So, D. The purpose of the pentavalent is to increase the number of free electrons. So, kung penta, that's 5 free electrons. So, may sobra isa. So, may increase of number of free electrons. Majority carriers in an N-type semiconductor are B. N-type, so electrons. Okay. Conduction electrons, not valence electrons. Holes in an N-type are the minority. Minority carriers. The term bias means A. Voltage is applied to control the operation of the device. To forward bias a diode, both A and C, external voltage is applied that is positive at the anode or P region and negative at the N region or cathode. When a diode is forward biased, C, the current is produced by both holes and electrons. Although current is blocked in reverse bias, there is a small current due to the minority carrier B. Yeah. For silicon diode, the value of the forward bias voltage typically must be greater than 0.7. When forward bias, a diode conducts current. So all the answers A, B, and D are kung reverse bias. When a voltmeter is placed across a forward bias diode, it will read a voltage approximately equal to the diode barrier potential. Silicon diode is in series with 1K and 5 volts battery if the anode is connected to positive. The cathode voltage with respect to the negative battery terminal is D, 4.3. Yeah, so 5 minus 0.7, 4.3. Okay. How about sa kwan? Problem solving. Ano naman din yung question din, no? So let Vs be 4 volts, R1 and R2, and R4 is 1K. And R3 is 500 ohms. And the diode is silicon, so 0.7. Solve for the diode currents. For the diode current and all resistor currents. Be, what's the first thing to do here? Nagagways pag solve ani, you could use Thevenin, equivalent circuit, or actually masayon ang isa, no, source transformation. Ay nakatry og source transformation ani, or na nag-attempt og source transformation. Mo pinakasayon, no, pero pwede lang nato i-solve sa dili nga nga pamaagi. Or for one thing, R1 man no? R1, 2, 3, 4. VR4 is equal to 0.7 still. So the same sila. So IR4 is V over R 0.7 milliamperes. Okay, next.
I will draw a planet. I want to make this. Why did you tanggal?
Trivial equations ta. Here and here. 4 minus VR1 minus VR2 is equal to 0. Because VR2 minus VR3 minus 0.7 plus minus is equal to 0. Equation 2. KBL ta dire. 4 minus VR1 minus VR3 minus 0.7 equal to 0. Equation 3. KBL sila ni. Okay. 3 equations, 3 unknowns. Tanda na to. Solving simultaneously. Kani makailan ni sa calculator. Hindi siya ma-solve sa calculator. 0, 1, negative 1, 0.7. Hindi pwede. Four minus VR1 minus VR2.
Mommy, the color is onions blue. No, Mom. Mom, the onion is not blue. But it's blue. That's why it's blue. It's blue, but it's not.
Gawa ko mga equations.
Oh, no.
Dili ta ka-assume pa nga same sila. Be, mesh na ako. Statement ako mag-mesh pero pwede ba? Try na to. Anyway, showing forward bias ikuan. If i-mesh na to ni
Yeah. Bye.
2k negative 1k 0 4. Negative 1k. Pwede ba ni 1.5k? 0. 0.7. Negative 0.7. 0, 0. 1k. Be? 2k. Negative 1k 0 4. Negative 1k 1.5k 0 0.7 0 0 1k 0.7. Okay. Nako'y nangakuha nga values. 3.35 milliamperes. 2.7. Same tag mga nakuha. Negative 0.7. Meaning aning negative is pa dito dapat ang kuan direction, no? Okay man na siya, ha? Direction naman na negative. So if tinood ni, if in fact mo yung mga currents, that would make I1 is equal to IR1, 3.35 amperes. I2 is equal to IR3, 2.7. Meaning, IR2 is equal to I1 minus I2. Yeah, basta ko man si I1. So, 3.35 minus 2.7. 0.65 milliamperes. So, now tayo IR4, IR3, IR2, and IR1. Diode ID is if tinod man galing nga ang direction ni 0.7 is pa didto. Kaya negative na ito nakuha. Meaning wrong atong assumption nga yan na yung direction. So dapat ingana. So meaning ID is current ni I2 plus I3. So 2.7 plus 0.7. 3.4. Diba? Yan, nigyan niya answers, guys.
Ay, sir, question lang, sir.
Ah,
Sa paghimo nimo sa matrix, sir, ba unsa na direction imong gitake para sa mga loop? Clockwise or counterclockwise?
clockwise.
Kay I think ang sign sa point 7 na bali.
You got Daddy got into your house.
Wait, Abe.
No, Daddy got
Clockwise. Sakto mo siguro. Okay. Paano man plus minus. So kung pikas, sakto, no? Sakto. May kayo mark ko. Be. Right. Kung asa mo din mo gawas ba? Yeah.
That's the middle. Oh no! Oh, it's a pig. Oh, this one, there's a pig over there. Stop, like stop. Oh no, no! It's for me, I will be. No, no, the pig is coming. Yeah. Me, if you can, no, I will.
Mm. So sayop na sila. 2.65, 1.3, and so the same 0.0, 0.7. At least nitugma itong 0.7.
Oh, Scotty! I will catch you and just
2.65, 1.3. So 2.65 minus 1.3, 1.35. So ID. So sakto gid ito, no? Or dito dapat ni. 1.3 minus 0.7. 0.6 milliamperes. Okay? So, paano nag-answer, guys?
Pareha na, sir.
Kaya na. Tanaw po niya. Kasi nakatry og source transformation eh. Mas para sa ko masayon eh kung source transformation. So, I equals to V over R kani mahimunig. Paspasan na ako ni. 4 over 1K. 4 milliampere. And parallel sa 1 case is 500. Then 4 times 500 is 2.
Ambulance comes. Video. Ambulance. Welcome. Be careful. Look like, whoa, what's that? Looks like the fence. There you go.
Mm.
Bye. Bye.
Yung final circuit, ani, is 1 volt, then kani 500.
And the photo.
Base ani, po na to ang diode voltage. Yeah. Ito. So, base ani, maning final, kung nag-perform tag source transformation, then mo na ito makuha ng final circuit. No? Mga equivalent circuit kibali sa all circuits apart from the diode. Na-transform to siya into 1 volt na source of 500 ohm resistor. Kung ito i-compute, ang diode current based on nga simplification is 0.6 milliampere. So, nakuha na gyapon na ito ni. So, the same gyapon mo tugma magid na, no? Kasi sa pang-analysis technique ang gamiton. So, based ani, pwede na yung mag-backtrack. So, di na ako ikuha nun kay taas-taas na. So, ang simplest, mas simple, no? Mas simple noon gamiton ng mesh analysis. No? Very fast and efficient. So, how about number 2? Let V in be 7 volts. $4K, $2K, $1K. This is V out. Solve for V out in all diode and current diode currents. KVL dire, masolve si V out. 7 minus 0.7 minus V out equals 0. V out is 6.3 volts. So if V out is 6.3 volts, V ni resistor 1, resistor 3, no? So R1, let's suppose R1, R2, R3 lang gyapon eh. So VR3 is equal to V out. Okay, parallel man si V out si R3, which is also equal to 6.3. So based on na, makuha na to ang current R3. 6.3 divided by 1K, 6.3 milliamperes. KVL na pod ta dire. Yeah. So 7 minus VR1 minus 0.7 is equal to 0. Therefore, VR1 is also 6.3 volts. So if VR1 is 6.3 volts, IR1 is equal to 6.3 over 4K. 1.575 milliamperes. Mukha na din na ito si VR2. Dito. Kanang KVL. Seven minus VR1, which is 6.3, minus VR2, minus 6.3, equal to 0. So VR2 is 7 minus 6.3 minus 6.3. Negative 5.6. So what does this imply? Meaning, akong direction sa purple nga line, meaning mo na akong direction sa akong current, assume ko nga mo niya akong plus minus. No? So sa ipong assumption, nagawa sa analysis, it should be that one. No? Para positive 5.6. Meaning, ang current directions, if we'll just look at this node, let's name this node A. If meaning ang current direction ani gikan kang R1 pasulod, gikan kang diode, or I mean padulong kang diode, and gikan kang R2 is pasaka. Para mag-make sense. Meaning, wala pa din natin solve ang diode R2. I mean, resistor current R2. IR2 is equal to 5.6 over 2K is 2.8 milliamperes. Pasaka. Meaning, let's say for example, this is diode 1 and this is diode 2. I diode 1 is equal to total ni IR1 and IR2. IR1 is 1.575, IR2 is 2.8, meaning ID1 is equal to 4.375. Diode 2 is dito. IR3 is panaog. So ID2 is the sum of IR2 and IR3. ID2 is IR2, which is 2.8, plus IR3, which is 6.3. So ID2 is 6.3 plus 2.8, 9.1. 9.1 milliamperes. Okay. Did you get these values? If wala, just try to review this one na lang. Okay? So that we could move on sa atong next na topic. Any questions so far? Especially this problem number 2. Klaro na ba ang kuan? Process sa solution? So kung gigamit lang is mostly Ohm's law and KVL and KCL. So wala akong naggamit og special methods, nodal ug mesh. Wala na questions, guys? If there are none, okay na. Sige. So if there are none, if napagin mo kuan, again, pwede na yun i-review. But if there are none, sige, move to sa next na topic. So far, the circuits that we have encountered with regard to diodes, no, have DC sources or direct current sources lang, just like this one. No? So that may be implemented using a DC power supply or battery. But more interesting ang applications sa diode circuits if the sources are AC, no, or alternating. So we call those applications as wave shaping. No? Ang circuit na handle og AC na sources are wave shaping circuits. No? So ilahang gina somehow process or manipulate in some form ang input signal or input waveform. No? That's why wave shaping circuits lang tawag. Ang tawag nila ani, no? So finish naman ta sa series diode and parallel diode configurations. The circuits that the first circuit that I'm talking about is the half-wave rectifier, or ang process ana is half-wave rectification. Okay. So katude circuit natong na learn before, the simple one where a diode is in series with a resistor. If ang source ani is an alternating current na source, kani nga simple circuit by itself is already a half-wave rectifier. Okay? So, mag-undergo ang signal og half-wave rectification if ingani ang circuit. No? So, yan na lang. No? This is the circuit for the half-wave rectifier. A diode in series with a resistor. Putang lang nato og reference. This one is our output. Okay. So output is measured across the resistor. Ang difference here lang is ang atong AC signal could be in any of these forms. 3 common forms lang ni, there may be more. Variations lang aning 3. It could be a sinusoidal wave, or a square wave, or triangular wave. So any of these could be the AC input signal. So what will it do? Or what will this circuit, no? What will this circuit do to the signal? How will it manipulate so to speak, our signal or rectify, no? Kay half-wave rectifier man siya. If mo na itong signal, sine wave, maybe, no? Positive 3, plus minus 3 lang ni siya, no? Positive 3 volts and negative 3 volts. Peak to peak, no? So 6 volts peak to peak. This peak and that peak. Ano? Remember, again, that the purpose of the diode is to pass through signal or voltage level that is above 0.7. Okay? So if this is 3 volts right here, muna yung 0, maybe yung 0.7 is na somewhere here. No? Na somewhere there. Okay? So it will only pass through signal above 0.7 and i-block ang any signal level below 0.7. No? Minsan pag negative 1 na siya, no? But it's still below 0.7. So yan ang i-block. So ang itsura sa atong output signal would look like this. I-block anything before 0.7, then pass through, then block na pod. Then the whole negative cycle, no? We call this the negative cycle because it's positive cycle. So the whole negative cycle is also blocked. So that's what the output signal will look like kung ipapass to sa half-wave rectifier. Like so. The diode only conducts when it's forward bias, therefore only half of the AC cycle passes to the diode to the output. During the positive cycle, ito nang i-discuss in detail. During the positive cycle, the diode is as if short, di ba? So gigamit niya din nga model is ang ideal model. So yan na ang itsura sa output kung ang input is positive. But if the output is negative, no? Meaning ang current is mag-flow on the opposite direction. No? So if current will flow on the opposite direction, that's why open circuit ang atong diode. So if open circuit siya, it will block current. That's why, diba, no? 0 volts. So ato tong i-combine ang signal sa taas ug sa silong. Yan na. Okay. So dagan man kain eh. This will repeat infinitely. So yan na ang output waveform sa half-wave rectifier. So any questions so far sa operation sa half-wave rectifier? Is it clear?
Clarify lang ba, sir?
Yes.
Unsa ang peak lower nga voltage aning kaning wala na negative 3 nga bitaw, sir, nga graph?
Asa
Zero,
ani?
0.7 or yapon, sir?
Asa nga peak? Ay, asa nga graph?
Kaning pinakaubos, sir.
Um,
Kaning kabalik-balik.
kani? Kanina?
Ah, yes, sir.
Pilay value ani?
Ah, sayang peak, sir.
Kuan, kung pilay value sa input signal. Oh.
So, 3
Ah,
volts sa yapon, sir.
3 volts sa gyapon sa
Okay.
kato nga example, no. So arbitrary naman to kung pag-choose og 3 volts. Sa kaning kuan notation gamit siya VM, no, maximum voltage. So mao gyapon ang value dire, no. Whatever is the maximum voltage sa input, mo put sa output, VM. Hiwi lang ni gamay pagka drawing pero so VM na sa tanan. No? So if ato i-summarize, this is the circuit of the half-wave rectifier. No? If ang atong input signal is a sine wave, atong output signal is ipapasok lang ang positive cycle. Ang negative is i-block. Yan lang. No? I guess it's as simple as that. Now, what is this one? No? What is this DC output voltage? No? Karoon na ba ako ni Incon or later na? Sige, karoon na lang, no? What is this DC output voltage? Right? So the formula for the DC output voltage is this one, 0.318 VM. No, medyo taas-taas ang pag-derive with an. We do not have the luxury of time para i-kuha na siya. Pero ang shortcut ani is VDC is equal to VM 1 over pi. So 1 over pi is 0.318. No? Pwede nyo i-check sa calculator. Una ang exact value, muna siya ang exact na value sa 0.318 1 over pi. Where VM is the peak AC voltage. This one, no? Peak AC voltage. But what is the DC voltage? No? Before, di ba, we've known that DC voltage is a constant na line. Ano, di ba? So, for example, 1.5 battery, tanaw natin sa oscilloscope, it will look like this. It will just look like, it will look just like a straight line. After na-rectify ang diode, like this one, no? Layo pa man kayo siya sa kuan nga itsura, di ba? DC will look like this man. Kani is ingana man. No? So how come na DC value? No? So what is this VDC? And why is it 0.318? Let's say for example, our VM is an AC signal nga 3 volts. No? Therefore, the DC voltage is equal to 3 divided by pi, 0.95. VDC is 0.95. So why is that, no? Kani, before I go further, would like to guess if ingani ang output if ingani ang kuan input AC signal without really kanang solving, how much do you think is the average voltage here? But when we say average is i-add na to tanan, no? Tanan kuan values. How much do you think is the average voltage of a normal sinusoidal signal? Meaning i-add lugar na to ni tanan. Would like to guess.
0, sir?
Okay, thank you, man. Why man 0?
Si Nico to, sir.
Because...
Si Nico
Ay,
to, sir.
Nico day. Ah,
Thank you,
sige,
Nico.
Nico,
Pareha
guys.
naman sila.
Ang lahi mo ni Pop sa microphone di sa screen. Anyway, sige Nico, anong 0 to Nico?
Because sir, like half the time is like pasaka siya through the peak na mo naog dayon to 0 dayon. Mo kunden siya. Basically sir, like para sa ko sir kay mag-cancel out ra ang mga negative
Kaya,
ug positive values.
okay, marag mo na ang
Out
usually
of phase
ginagamit
siya, sir.
nga. Di man out of phase, no? Di man wala man tay reference ani para maka-compare tag phases, pero medyo advanced na gamay ng phase, no? So sige lang. Pero mas commonly used tong ginagamit nga term tong giingon ni Nico nga mag-cancel out, no? Yeah, mag-cancel out na sila. That's why 0 volts ang average, no? 0 volts ang or 0 ang average voltage sa kanina signal. Now, if 0 siya, but ato ni siyang di lugar nato ni siya makuan ma-use, no? Magamit kay effectively 0 man day ihang output nga voltage kung kibali atong i-total. Dili ko di ana pero it's not really like that. But mathematically, yeah, mo confirm no ng mataan ni na 0 ang average, just by the fact na mag-cancel out sila. Now, before I go further na po, naday ko isa ka concept na limtan. Rectification is the first process to what we call or first step siya sa block diagram sa DC power supply. Okay? DC power supply. Okay? So what is a DC power supply? It converts an AC signal, kung practical pa, 220, into something nga usable sa electronic devices like 5 volts, no? The best example of this one is our cell phone charger, no? Or mobile phone charger. Diba? Saksak na to sa outlet ang atong charger, 220 biya na. Pero kung ato i-measure using voltmeter ang atong output sa USB nga cord, na mo gawas dito nga 5 volts. So how can that be? Aside sa gipa-step down niya from 220 to 5 volts, gi-change pagid niya from pure AC to pure DC signal, no? So it involves many steps and many circuits, but the first one is the rectifier circuit, and this is it, no? So this is it, rectifier circuit, this one. Okay. Now, after sa rectifier, actually, ang next next na circuit is what we call a filter. No? Filter. Medyo complex pag ni siya nga topic, pero long story short, ang filter is i-filter out, no? Dili niya ipapass, dili siya the same sa diode, so don't get me wrong. When you say diode, kuan man siya, no? Mag-conduct siya in one direction, dili siya mag-conduct in the other. Ang filter is totally i-block gid niya, no? Ang isa ka signal, no? Naka-off gid siya all of the time, no? When you say filter, long story short, especially sa DC power supply, ang i-filter out niya ang signal, no? I-filter out niya ang signal. So, and this filter is particularly an AC filter. Okay, wala man gyud siguro yung DC filter, no? Alternating current man gyud ang ginahandle sa filter. Okay? So, long story short, if AC pa gid ang atong signal, no, AC, then ipaagi nato siya og filter, totally mawala na siya, no? Totally mawala. Okay? Ano man, because a signal is composed of sine wave, man gini, di ba? Sine wave. One of the uses of a filter is i-remove niya ang sine and cosine component sa isa ka signal. No? So, i-remove na niya. So, dapat ipagawas na to ang iyahang constant na component. It should be, okay, this signal, we should convert this one into a signal that has a DC component, no? A constant component. DC plus sines and cosines. Para, kung ipagi natin yung filter, ang sine o cosine lang mawala. Si DC voltage ang mabilin. And one way to do that is to pass through first the sine signal before sa filter, before sa filter, papass to sa atong rectifier para somehow ma-extract nato ang DC voltage. No? So, that's the DC voltage, this one. And the value of it is 0.318 of the maximum voltage level of our input signal. So, nigamay siya tuod, pero at least atong na-extract. Okay, nakuha ninyo? So, kung ato ning i-visualize, yan naman ang atong input signal, right? Sine wave. Okay, bali, i-breakdown lugar nato. Ang mag-explain aning mathematical concept, next time, pumansin nyo ni maagian. Pero, para dali lang, no? I-break down lugar natin nga signal na this is a sine wave. This is a sine signal. A sine signal always has sine components, of course, cosine components, and a DC component. No? So, medyo weird siya tanawon. Pero ang sine wave, this one, is composed of sums of sines and cosines and a DC value. No? So, naana siya. No? Tinuod ni siya nga phenomenon. Ang maka-explain ana is a concept that we call Fourier analysis. Okay, Fourier. So, ang buhaton sa rectifier is readily ma-isolate na ang DC component. No? And the value of this one, although ang itsura niya is ingani pagihapon, this one. Especially this one. So, this signal has sines and cosines and a DC component. No? And the value of that DC component could be calculated using this formula. No? So, medyo taas-taas siya. Usay di na nagkainig-ganig. Usay di na ganit ka. Yun yung explain. Pero muna siya ang reason behind or the explanation behind what is the DC output voltage. Even kaning slide, gi-assume na niya diretso, no? Kung ano niya, i-state niya na lang niya as is that the value for the DC voltage is 0.318 times Vm. So that's the explanation behind, no? Muna siya explanation behind the DC output voltage. So, gamay noon, no? Mas gamay ra, pero at least naa. Kaysa sa wala, di ba? Kaysa sa pure sine wave, no, nga dili usable because zero ang iyahang average nga signal, nga average nga DC value, average value. So to extract that one, we use a rectifier. So from 3 volts, example, nigamay siya to 0.95 volts. Small, but at least not present. No? So before I go further sa peak inverse voltage, mag-lecture na lang ko sa full wave rectification. No? So we have 2 types of rectifiers. One is that one, half wave rectifier. The other one is this, full wave rectifier. So there are 2 types of full wave rectifiers. One is the bridge rectifier that looks like this circuit right here. No? So nadiri ang atong AC signal gi-connect. Yan na. Then ang atong load is naka-orient sa ingani nga position, no, nasa tunga, with a positive here and negative. No? So for current to flow also across the load, because ang orientation sa load is nadiri ang positive and nadiri ang negative, current should flow in that direction. So muna itong gusto may tabo. Current should always flow in that direction. So that para na current can flow sa load. So remember that our source looks like this. No? One part positive, the other part negative. So ang bridge rectifier, at the positive half cycle, kanina lang, no? At the positive half cycle, 2 of these 4 are forward bias and the other 2 are reverse bias. So kung positive siya, dili mo agi atong current, no? So which of the 2 diodes kaha ang mo on? Kay after passing through this node, munaog man na siya, either anang diodes. So which do you think of the 2 diodes ang on at the positive half cycle?
Dito.
Okay, dito, no? So at least nag-pay off po ang atong na-learn before. We know na si dito ang mo on. So reverse bias na eh. Reverse bias. After dito, okay, here, wagi siya sa resistor, which is dapat lang yun, no? In that direction. Mupass through siya kay D4, dili.
Dili kay reverse bias man ang D4.
Yes, dili. Kay kung dito siya mupass through, ma-reverse bias niya si D4. So, dili. And, muagi siya kay D2 eh. Then, balik na din siya sa source. No? So, at the positive half cycle, si D2,
Sir,
yeah,
dili siya maagi sa D1 na diode, sir?
dili. Di siya muagi kay mubangga man siya sa direction sa current ni D1. Nalang mas detailed nga explanation nga ko visual. Pero dili lang ta mag kulis-kulis.
Okay, sir. Kita na ako, sir. Thank you, sir.
Sige. Okay, Nico. So sa negative half cycle, this one, dili na pod ang atong current in that direction na pod. So dili siya kaagi kay D3 because ma-reverse bias man si D3 kung dito siya moagi, dito siya kay D4. After passing kay D4, di gyapon siya kaagi kay dito. Bangga man sila sa current direction ni dito. Mulaw sa po siya sa load resistor nato. Na. And ato siya kay D1. So, di siya magi kay D3 ha, kasi D3 reverse bias na inaan. No, ganiya pa. So si D1 is on and then back na po siya. And so on so forth. So unsa itsuraan ni sa kuan, no? Unsa itsuraan ni sa output waveform. Okay? During the positive cycle, this one, Pass through siya, no? So kani nga ang ganha, ang VO is naka-orient sa atong resistor, no? Even though at least klaro naman noon sa positive half cycle, no? Ang medyo libog dire initially is nganong sa negative half cycle is positive man ang output, no? Anong positive? Na. Or in simpler terms nganong nag-flip, no? Nganong nag-flip ng output, no? Ang input is ang iyang gi-flip, kibali. Because remember, VO is measured across the resistor, no? The resistor. All of the time, whether positive cycle or negative cycle, the current will always pass to the resistor in a positive nga way man, no? So if the positive half cycle is denoted by the purple nga arrow, no? Sa positive half cycle, mo flow man ang current kay resistor from positive to negative man. And even if negative half cycle, pero ang paglabay niya kay resistor is still from positive to negative. So it should be expected na ang output signal would look like this. So this is the output of a full wave rectifier. So mara siya duha ka half wave na nakakuan gi-operate simultaneously. So supposed to be ana man to kung half wave rectifier. Then ana pod, no? So ato na i-combine, mara siya sine wave nga gipang flip. More explanation sa pag-agi sa current flow. So 4 diodes are connected in a bridge configuration. This time, if you'd compare this from previous na half-wave rectifier, the DC voltage is na times 2. No? So 0.636 times VM na dayon ang VDC. So mas ni Saka, kibali siya. So using our previous example, if atong AC is 3 volts, if half-wave rectifier lang, ang DC voltage niya is 3 times 0.318. So 0.954 volts only. But kung full wave, 1.9. 1.908 volts. So na times 2. So mas daghan tag makuha, no? Mas daghan tag makuha na voltage out of the full wave rectifier kaysa sa half wave. So far, any questions regards sa full wave operation, a full wave rectifier nga operation? Is it clear ba? So we have two types of full wave rectifier circuits. One is this one, the bridge rectifier. The other one is the center tap rectifier, no? Using a center tap transformer. So the same gapon sa as previous, no? Same gapon as previous. The same ang output waveform, no? Uli nagbago. Ang nag-change lang is the addition of the center tap transformer. So instead nga directly connected ang atong rectifier circuit or diode circuits sa source, napay transformer nga na center nga node. or we call this one a center tap. Para magyapon iyang operation during the half cycle, during the positive half cycle, it will flow in gawas ang atong current dire, no? So in this direction tibali, and on the negative cycle it will flow here. Parang output the same gapon as earlier, positive then negative. Ang difference lang niya sa full wave rectifier nga bridge, same guys lang computation sa VDC. Ano naman, kaya naman sila output waveform. Para naman gyapon. But yung difference is, well, of course, number one, it uses less number of diodes. But nasa disadvantage, no? Actually, mas disadvantage siya kaysa sa bridge rectifier. Yung disadvantage ani is this one, no? The computation of the lagi dire. The disadvantage of this one, of the center tap transformer over the bridge rectifier, is with the peak inverse voltage, no, PIV. So before that, what is peak inverse voltage then? DI. No? Balik tao na sa half-wave rectifier. No? Peak inverse voltage, no? Or peak reverse voltage. Hani siya makita sa diode nga kuan, no? VI curve. Mao ni iyang positive nga kuan, voltage current nga characteristic, yang negative is ingani, no? Peak inverse. This one. So this value is daghan kayo siya name, no? Natay Zener voltage, natay breakdown voltage, or reverse voltage, or in this case the peak inverse voltage. Okay? Peak inverse voltage, this value, no? Paano na to example? Let's say this is negative 20 volts. So any value below negative 20, bisan pag negative 15 pa na, or negative 5 to 0, pwede ma-block ni diode. No? Pwede ma-block ni diode. Any value above peak inverse voltage is dili na ma-block ni diode. While in fact, mag-allow na for current to pass through. But if rectifier diode siya, once na-reach ang peak inverse voltage, automatic si diode is mo guba, no, mubuto. So we don't want that to happen. So it's important for us to know what is the peak inverse voltage of each diode. No? So once we know, where will we get this one? Sa specification sheet. No? So specs. Specification sheet. So once we obtain what is the peak inverse voltage of the diode, we should make sure that our input signal is less than that. No? So mas greater dapat si peak inverse voltage kaysa kay VM. No? So PIV should be greater than the maximum input signal voltage. Now, for half-wave rectifiers and full-wave na bridge rectifier, that's the formula, no? Peak inverse voltage should be greater than VM. Wala man dito sa slide, so ako lang isulat. Whereas, for full wave na center tap, the peak inverse voltage should be greater than twice the VM. Okay, correct ba ne? Center tap. Yeah, 2 VM sakto. So peak inverse voltage should be greater than 2 VM. No? That's a disadvantage, no? So dapat mangita tao much larger, no, na nakuan na diode ratings if we want to utilize the center tap, no, nga configuration, because PIV should be greater than twice the VM man. Well, anyway, dili man gid ni commonly used na configuration ng full wave nga rectifier. Ang pinaka-common ani nilang tulo is this one, no? Wala man gyud siguro application karon nga gagamit og full wave rectifier for rectification unless yung use is clipper, no? But for DC power supply, full wave rectifier gid ang ginagamit ang atong gamiton, no? Full wave rectification. Not only does it provide twice, no? Twice the DC voltage level compared to half wave rectifier, but with respect to peak inverse voltage, di na kailangan i-multiply og 2. So kung pila ang peak voltage level VM, mo pod ang value sa atong peak inverse voltage nga pangitaon, no? Or of course greater than that, much better. So sa kaning nga mga examples class, no, wala gid kayoy no, wala kayoy computation. At least sa kaning nga level wala kay computation, because defined naman good, no, defined na ang circuit for for full wave rectifiers and half wave rectifiers. Mo naman gid to, no, wala na tay lain pwede redesign pa sa ingani nga sa ingani nga configuration, or sa ingani nga sa kaning mga circuits. Define na daan ang circuit for the full wave rectifier and the half wave rectifier. So what we need to know only is unsa expected nga output. Okay? Without using any computation, ma-visualize naman nato unsang output waveform sa full wave rectifier. Now, side note lang ni siya before we end. Before ang side note, kani di ay malag-wrong ni siya, oh. Kato nga mga formula is this one, ideal, no? Ideal nga approximation. If we use the practical, meaning i-consider nato ang 0.7 nga value ni resistor ni diode, dapat part siya sa formula, no? But dapat ingani ni siya, oh. Wrong ni siya nga slide. Dapat naka-bracket na siya. For us to compute the VDC. Pero, if if VM is very much greater than the barrier potential of our diode, in this case 0.7, pwede na magamit og ideal na model. If VM is nasa mga 50s to 100s nga level, 100 volts, di naman kayo maka-matter ang 0.7 kasi times 2 pa na siya. So, pwede lagid kaninga condition na itong gamitin. Ideal conditions. Side note lang, no? Side note. Pwede ta maka-create og full wave rectifier nga naka-combine ang bridge ug center tap class, no? So yan ni may tabuan na. So of course, makuha niya ang advantages and disadvantages of both. no, of both nga kuan configurations, makuha niya ang mas dako nga peak inverse requirement sa center tap, and of course makuha po niya ang times 2 nga DC voltage computation for a full wave rectifier. So natay transformer here. But instead, naingana lang, butang na to bridge. No? So, itong yung ganyan filter, no? Filter ni sa ang next ng kuan. Next na circuit, we filter gapon. Kanina ka-ground ni siya. Yeah, and so, what would this do? No? So, may tabuan eh. To the very end sa kaninga kuan nga towards the end ng part sa kaninga circuit, pwede ta maka-create og positive nga DC voltage and negative nga DC voltage. Okay? Kay kung pure lang bitaw nga full wave rectifier nga bridge, ang output nato ani ang pwede nato mabuhat nga power supply is only kuan positive DC voltage lang, no? And the same gyapon sa pure nga center tap. Ang output ani is only a positive DC voltage. But what if our application calls for both, no? What if ang atong application is kinanglan plus minus VDC nga output? Okay. So remember this one, na pwede ta magbuhat og combination sa bridge rectifier and center tap na configurations para ang atong output is na ay plus and minus, no? Di lang kayo ko sure kung kanang atong mga charger nag-require ba na siya og plus minus, no? Or naba na siya negative nga DC voltage nga output sa iyang mga pins sa USB nga cord. Pero one example of this one is, let's say ang atong mga kuano, ang atong IC nga chip, no? IC nga chip. And this chip is an integrated circuit for an operational amplifier. So si operational amplifier, manginanglan na siya og positive nga supply og negative nga supply. And most chips are like this po ba, no? So kinain siya positive nga supply, let's say for example positive 5 og negative 5 volts. No? So how will we create a negative 5 volts? Or we cannot create a negative 5 volts if mo lang niyang atong circuit, no? Pure lang nga bridge o pure lang nga center tap. So we should take advantage of both and combine both circuits para ta maka-create og power supply nga na ay positive nga voltage output nga capability og negative voltage output, no? So gani more like trivia naman gid ni siya, no, but useful gid ni siya when we try to create our own power supply circuits. So I guess that's it for now, no? We'll end here for full wave rectification. To summarize what we've discussed, dali naman gid kaayo, no? Basta kayang half-wave rectifier, ang ipapass through lang niya ang positive half cycle lang sa signal. Whereas ang sa full wave rectifier is ipapass through niya both the positive and negative. And more than that, ang negative half cycle sa signal is iyang i-shift sa saka para yan ng itsura. No? So if you've understood that, dili na ta maglisod, no? So pag-understand sa other wave shaping capabilities of the diode. So apart from this, any questions? May pangutana? Wala na? Are you still there pa ba? If wala na, pwede na tayo mag-dismiss class.
Bye, sir. Thank you, sir.
Thank you, sir.
Hi, sir.
Okay. Sige,
Ay,
review lang
thank you,
ninyo
sir.
Thank
kuhaan
you, sir.
video.
Thank you, sir.
Sir,
Okay.
okay, question
Thank you,
out of
sir.
curiosity lang, sir.
Sige.
Ay,
Saman.
since ang full bridge rectifier mong sir kay, di ba ka ng ang iya mga output kay mo peak siya. So mura siya pulsating. Patong iyang i-flip ang katong negative, ma-positive siya. So ga-pulsate siya between iyang peak voltage of 5 down to 0 back up to 5. Saan na to para ma-rectify
Pulsating
siya
yapon.
nga dili siya pulsating ka ng state DC gyud siya.
Straight na. Good question. No? So, ang rectifier, whether full wave or half wave, practically full wave mga itong gamitin, no?
Mhm.
So, ang rectification, first part pa na siya kaya sa process of transforming an AC na pulsating,
AC to
no?
DC.
To DC. First part pa na siya.
Okay.
Daghan pa, napasiguro yung mga tulo or upat ka circuits. Ang second ato, ako na-mention earlier itong filter.
Filter. Sige, wala
Filter.
pa man na discuss sa ang filter, sir.
Pero
Kasi-
di pa mo sila dili nga subject gani ang filter.
okay. Kay ang focus sa mato is diodes, di ba, sir?
Diodes pa man.
Diodes and amplifiers ba? Sakto?
Diodes amplifiers, oo.
Sige.
So,
Ikaw kay sir, ha?
sige, ano to?
Yeah, mura to akong question
Sige.
actually.
Pero kung
Pwede ba-
mas better bitaw nga imo gyapong makita kang kuan ato na sa YouTube. Search nimo ang DC to AC to DC nga power supply nga
Converter?
process.
Sakto.
Converter, DC to
Oo.
AC converter.
Okay, nadamdaman mo guna ko, sir, kay sa una kasi iba ako tan-aw kanang hilig man ko tan-aw gud og electroboom mong ganun.
Nagtrabaho mo.
Oh. Like, nadamdaman ako ang iyang mga videos about rectifiers and like medyo nasabtan na ako karon nga na ko'y context. Okay.
Especially kung i-review bitan example mahuman na ta sa first sem nga electronics 1 or electronics 2 next year. Then i-review nimo tong kuan mga electroboom nga videos mas ma-widen imong perspective sa iyang ginapang
Really, sir.
buhat.
Pag mag-make sense na din siya.
Make
ka
sense na.
Para siyang mad scientist.
Sa una, no? Even before, kita mo ko ato, then wala ko idea ni. Ako lang yung makuha sa iyang ginakuan kay ginahulatan ako kano sa magbuto, unsa iyang mga tips para dili
Mubuto.
ana dili dangerous. Pero after nako ma-learn unsa gid ang mga kuan sa iyang mga ginapang kuan nga circuit, especially mga components, diodes, transistors, saya pa ko kasabot. Kasi may sa inyo apuhon.
Yes, sir.
Mm-mm.
Sitingo kay sir, ha?
Sige, Marta.
Bye-bye.
Okay, bye-bye.